Okay, this video is focusing very specifically on finding, it's kind of like the algebra part. So like, let's say you have this example, this function 2x plus 1, and you want to find the area underneath the curve. You know that there's another way to do this as well, so I'm going to throw another AKA in here. There's a lot of ways that this can be kind of like considered. So we can also look at this as the area under this graph. So we're up at 1, we have a slope of 2. We want to go from, let's say this is 1, 2, 3, 4, 5, 6. So this is 5. This is also what we're trying to find, is this area right here. We're trying to find the area of this trapezoid. So all of these are going to give us the same answer, no matter what. Whether we use the geometry way, we can put a nice straight line, and we can draw a simple shape that we know the area of. This is a trapezoid, by the way, with a base of, I think if we use the function, this is 2x plus 1, right? This is y equals 2x plus 1. If we use the function, we'll find that this is 11 high, and this here is, I think, let's see, 7. So if we find the area of that, it's 1/2 base 1 plus base 2 times the height, the width of this trapezoid is actually its height, so times 2. So the area of this should certainly be 18. And all of our answers should come up to that. So when you have this example, it says find the area, it might give it to you like this, and you need to match it. So hopefully this video is designed for you after you've seen, after you've matched a couple of the limits, which is this bottom craziness. Once you've matched some of these with these, or you've matched these with these, there's a nice little handout that I like to do with this. Once you feel comfortable getting this, once you feel comfortable writing this, I want to see if we can take this and just do the algebra. So let's understand that this question can be solved this way, can be solved this way, and can be solved this way. And there's all different methods to get there. I want to focus on this bottom part right now, and just the algebra. So constantly, I'm going to kind of keep reminding you that we're just focusing on the algebra. Let's say you know how to set this up, you understand sort of what it means, or at least you can get there. Let's talk about just doing this and getting a number for it. Okay, so here we go. I've also put a little disclaimer there that I is not the imaginary number, no relation whatsoever. And we're going to treat n like it's a constant, so just like it's a 5 or an 8 or a 2. Okay, so here we go. All this craziness is going to start happening. So you see this blue? This is a constant. We can pull it out here, or we can pull it out here. However, and we can pull it all the way out in front of the limit if we want, but it's probably better to pull it in front of the summation for now, because we're going to want to take the limit of whatever these n's are before we really pull them out. So I'm going to go ahead and pull that 2 over n out, and then I'm going to have this summation. So I'll just keep writing the summation. I'm just going to do this. It's kind of lazy. I equals 1 to n. And then we have, inside here, I'll just distribute this. So I've got 6 plus 4i over n plus 1. This is all inside the summation, so maybe a parenthesis would help. And this is all the limit as n is going to go to infinity. We're going to have a number of bars there. So disclaimer, we're treating n like a constant, and now we want to start talking about the algebra here. So we see that here, we can break this into a bunch of summations. First thing I'd like to bring your attention to is, there's a lot of ways to do this, but I'm going to make this a 7. So I'm going to say now we have the summation of 7. And then, I'm also going to say we have plus the summation of, I'm going to take this 4, I'll just write 4 over, I'll show you what I'm going to do with that. What did I say about n and the 4? They're both constants. So we can also take the 4 over n out, and we have the summation of I. So there's that, and there's this. So that is all of this stuff done out. So this right here, I just changed into those green and red things underneath. In other words, the summation can be broken down. So sum of A plus B is also known as the sum of A plus the sum of B. That's important. This is the sum. Okay, I equals 1, right? I equals 1. Not great with my notation on that, but I'm doing what I can. Break it into pieces. Pull out all the constants. So it's just stripped from everything there. It's just i's inside or just a number inside, things like that. So there's where we are, but what should have been outside the whole time? Well, I like sometimes to use a lot of parentheses. The 2 over n was still there. The limit as n goes to infinity. Okay. So there's that. I'll bring down this disclaimer so we can kind of just keep it at the forefront here. We're treating n like a constant, so that's why we're kind of like pulling it out in front of things and stuff like that. So now I just need to use the summations, the summation formulas from the book. Let me just pause the video and grab those for you. They should be in your textbook. Okay, so hopefully these formulas look familiar to you. They're in your textbook if you're using the textbook that we're using. I believe around maybe page, let's see, 200, sorry, and 91. On page 291 for you. So let's talk about it. Obviously, this is not changing. So just like when you're factoring, this limit as n goes to infinity is not going anywhere. This 2 over n is not going anywhere. But that's not really much yet. So the question is, what does this mean? So is there an I in there? That's this situation. Or is there an I squared in there or an I to the third? No. None of those are the case. But C in this situation is a constant. Okay? So C is also a constant. So C could equal 7, C could equal 9, C could equal -2, whatever. If you have a number inside a summation, right, what we're saying is we're going to add up the number 7, let's say, from I equals 1. Let's say we add it to 3, okay? What does that say? It says if you're taking 7, you're going to add it 3 times. 1, 2, 3 times, and the answer is 21. So what's happening is that when you're adding it 3 times, it's really just 3 times 7. When you're adding it n times, it's going to be n times 7. So what am I trying to say to you? I'm trying to say to you that this is 7n, according to that formula that I underlined in green, that formula 1, summation formula 1. Okay, let's hope that that's all right, and take it to the next one. So let's leave parentheses, try to keep it order as much as I can. Now let's go to the green one. Well, we know the 4 over n is just hanging out. That's good. And then we have exactly this in the box. Can you look up exactly that from the bottom? Yeah, it's right here. So I'm just going to replace with what they have there, which is n plus 1 over 2. All right? So here's where we are. And we are just going to try to see if we can figure this problem out. We've now gotten rid of the summations. So a big part of it is understanding how the summations work. You can break them into 2, for example. You can break them down. You can combine like terms. And then you can pull out constants, n's, and things like that. So a couple of things that are kind of important here, I'll kind of highlight. How we pulled out this 2 over n, right? How we pulled out this 4 over n. And then even though there was a constant here, how we realized that it was this formula right there, number 1. So that's kind of important. Once we have the exact formula, we just replace it from here. Okay, so hopefully that helped a little bit. And here, same thing. We combine the 6 and the 1 to get the 7. So that made sense, hopefully. So now, let's go down and see where we can go from here. That's just a star that I drag around. It's not the best tool. Okay, so let's talk about this. We get the limit as n approaches infinity. We don't have to go crazy here. I'm going to take 2 times 7. I'm going to have 14n over n. Here I'm going to have, if I distribute this here, I guess the 2 will cancel this 2 in this situation. I'll have n squared on the bottom, so I'll have 4n times n plus 1 over n squared. Okay, so we're just taking the limit of both of these things. Well, limits, you can take the limit of this and then the limit of that separately. So you can take the limit of this and then take the limit of that. Some of you are going to want to like go ahead and get a common denominator. You don't need to do that. That's crazy. So I'm going to take the limit as n approaches infinity, and I'll just show you what I'm talking about. In other words, the limit of the sum is the sum of the limit, and you know, the sum of the sum of terms is the well, I don't know what I'm trying to say. Summations and limits kind of work in that same sense is what I'm trying to get at. So we need to take the limit of 14n over n as n goes to infinity. The exponents are the same because we have the same power. We know the answer to that is 14. Boom, done. Now we need to look at this one. This is the limit, so we're going to put the plus sign here. This is this plus sign of 4n times n plus 1 n squared. What's the leading coefficient? Even if we distributed this out, we don't need to. But if we distributed this out, we get 4n squared plus 4n over n squared. We didn't need to do that. But the leading coefficient tells us that the exponents are the same, so we divide those coefficients, so that's plus 4. The limits have been taken, and we get a final answer of 18. So go back and look through everything that we did, and we'll remember that the area under that curve was exactly 18. You can kind of see that right here. Let's see what I'm talking about. You can see that the area under the curve was exactly 18. Now, just because I can, I'm going to do something kind of crazy and just kind of show you. Maybe it'll help you to see this. This is a bonus feature, so you can stop right where you are. That's all you need to know at this point. But I'm just going to kind of foreshadow a little bit because you're probably wondering, if these are all the same thing, then this should also equal 18. This should somehow equal 18. So I got 18 by this whole disaster right here, this whole mess with the limit sum. Definition of an integral, all of that, everything I just scrolled through. On the right side, with that shape, we found 18. The top, obviously, we don't really know how to do. These are 3 ways. But obviously, this has to also equal 18. And now the question becomes, how does it connect to what we've been learning? Can you antiderive this? If you antiderive that, you get x squared plus x. And yeah, you'd have a plus c here. Okay? So if you think about this for a second, this is what you got when you antiderived it, right? Well, I'm going to put the 5 and the 3 over here. The same 5 and the same 3 from up there, okay? So just so you know, this is the 5, the red 5. Just so you know, this is the same 3. Again, you don't need to know this. This is a foreshadow part. I'm going to plug the 5 in. So I'm going to have 5 squared plus 5 plus c. I don't know what that is. And then I'm going to plug the 3 in. And I'm going to subtract everything from that. So I'm going to have 3 squared plus 3 plus c. And I'm going to simply do out this math. So 25 plus 5 plus c minus 9 minus 3 minus c. That's gone, plus c. We didn't really need that. We got 30 minus 12, and 30 minus 12 is again 18. This has not, everything that's on the screen right now, you haven't learned at this point of the playlist. If you're doing the graded homework on 4.2 or you're working on just area and stuff, you haven't gotten here yet. But it's all connected. And eventually, antiderivatives are going to be the shortcut that help us out. So if you want to check your answer by that, so it's okay. And let's just do a quick recap. Okay, it didn't take all that long. I went as slow as possible. What are the keys here? Being able to set it up, of course, once you get here. But a lot of you are probably at a point watching this video where you're able to do that. So just simplify, do the algebra, okay? Pull out the delta x, this thing, all the time. Pull it out right away. Because it's always going to be its own thing. Put it right here, because we're treating this like a constant. Then combine similar terms, split it into 2 sums, and try to get these formulas. Once you do that, you don't need to go crazy making a common denominator here. You can just take separate limits, and the powers should be the same. Both powers of 1. This is a power of 2 on the top and a power of 2 on the bottom. If you're getting powers that aren't the same, there might be an issue. I can't remember a situation where the exponents weren't the same. So here's where we're supposed to be. Hopefully you found this video helpful. I'll see you in the next video. Peace.